Hello everyone, my name is Ayush Singh, roll number 35, and along with my teammates Krishna and Kalyani, we have developed our operating system project titled Secure User Friendly System Call Interface. System calls are an important part of an operating system. They allow users to communicate with the system and perform operations like reading, writing, or deleting files. However, direct access to system calls can create security risks such as unauthorized access, data misuse, and system vulnerabilities. So the main problem we identified personally was that system calls are not secure when accessed directly and they are difficult for students to understand practically. To solve this, we developed a system that provides a secure and user-friendly interface for executing system calls. Our main objective of our project was to implement authentication so only valid users can access the system, to apply role based access controls like admin and user, to ensure all system calls go through a secure middleware layer, and to maintain detailed logs of all system activities. Uh, as you can see, our system works on a layered architecture where users interact through a web interface, requests are processed by backend servers, and system calls are executed securely using C programs. This ensures that every action is verified before execution, improving both security and reliability. This project helps in understanding real world systems, protect system level operations, while also making OS concepts easier to learn. Now, my teammate will explain the system architecture and give you a brief demonstration of the working of the project. So, thank you.
Hello everyone, my name is Krishna and I'm going to show you the working of this project. So you can see at first we have this login and register page. Let me just first log in with the admin credentials. Okay, so you can see we have this kind of dashboard where on left hand side we have this execution context and on right side we have this audit stream. So let me just enter the target file name. We have this data.txt and as soon as I click on read, you can see the sample data. Likewise, I can also write on this file. For example, hello from admin. Now the file data has been modified. We can also delete this file on clicking delete button. Now the file has been deleted. And you can see all these actions in the log on right hand side. Moving forward, we have this manage user and permissions where admin can change the permissions given to the user. For example, we have this user. I have only given read permission to this user. Let me just create a new user. For example, user2 and password. You can see the register is successful. Okay, so you can see admin has one pending request. I have to click this approve to make sure the user has been registered. So you can see user and user2 both have this read permission. But let me just modify the permission of this user2. For example, I'm giving user2 read and write permission and save. Now let me just log in with user2. Now you can see user2 can even write on this file and read this file. Now let me just log in with the user1. As you can see, user2 cannot write on this file because it does not have this permission from admin. It can only read this file.
Now I shall explain the technologies used in our project and how they work together. The system is built using a multi-layer architecture, combining the front-end, back-end, and system-level programming. For the core system, we use C programming, where modules like authentication, secure system calls, and login are implemented. For the backend, we use Node.js with Express, which act as a bridge between the front-end and the C programs. For the frontend, we have used HTML, CSS, and JavaScript, which provides an interactive user interface. The backend uses the child process module to execute the C program securely. Data stored using the file-based storage, including the user data and system logs. Overall, this architecture helps stimulate how real-world operating system manages secure system calls. Now, coming to the result of our system, a project successfully demonstrates how system calls can be executed through a secure middleware layer rather than using the direct access. We implemented authentication and role based access control, ensuring the only authorized users can perform specific operations. For example, admin can perform all the operations, whereas users has limited access and guest has restricted access. The system also maintains a login mechanism where every action is recorded with username, timestamp, and a status. This helps in monitoring, debugging, and security auditing. We have also achieved a smooth integration between the frontend, backend, and the C modules, which is one of the key outcomes of our project. Overall, the system behaves like a simplified, real world secure OS environment. In conclusion, our project provides a practical implementation of secure system call handling. It helps in understanding how operating system enforces security, access control, and monitoring. This project builds a gap between the theoretical OS concepts and real-world implementation. Thank you.